So in yesterday's class, we have discussed about how to integrate or how to find the antiderivative, which was very simple. Within 1 or 2 steps, you are able to find the answer. So the next method used in integration is integration by substitution method. So let us take an example. So you have, you're supposed to integrate integral 2x by 1 plus x squared into dx. Okay, the problem given is integral 2x by 1 plus x squared into dx. So how to integrate this? We do not have any formula. We have formula only for x power n. Integral x power n is x power n plus 1 by n plus 1. So how to integrate this? So the basic thing which you want to see is that, suppose if I am going to take this entire term with some variable named as t, and when I differentiate, I'll be able to get the numerator. Okay, so this variable, the bottom, I'm going to take it as t. Okay, and when I differentiate in terms of this variable t, I'll be able to get the numerator. So now let us consider. So you take, let t is equal to 1 plus x squared. What I'm taking? Let t is equal to 1 plus x squared. So now when you differentiate this t, this becomes dt is equal to, differentiation of 1 is 0, and this becomes 2x dx. So now you can see that this 2x dx is there in the numerator, and what is that actually? It is nothing but dt. So 2x dx is dt. So I can replace this 2x dx, I can replace this 2x dx as what? dt. So this following integral, let me assume this is 1. So 1 becomes, so what is 2x dx? It is nothing but dt. 2x dx is dt. So dt, and what I have taken as 1 plus x squared, I have taken it as t. I have taken it as t. So integral dt by t is nothing but what? Log t. Integral dt by t is nothing but log t plus c. And what is this t I have assumed? It is nothing but log of t is 1 plus x squared plus c. So this is your answer. So hope you understand integration by substitution. You see the numerator and the denominator term. When you take one term in terms of one variable, you will be able to get the numerator, the other terms. So in such a case, here I am going to take 1 plus x squared as t, and when I differentiate, I am able to get 2x dx. This is 0. 2x into dx. So I can replace this 2x dx as dt, and this is nothing but t. So what is integral dt by t? It is nothing but log t. So log t, log of 1 plus x squared. So what is the main purpose of using substitution method is that, given an integral, you can just make it in the form of a known formula what you have learned earlier. So if you can bring it of this known form, you will be able to easily integrate the given integral. So this is what we follow. Usually under a short answer, you can expect a question from the substitution method, because the step is very simple. Within 1 or 2 steps itself, you'll be able to get the answer. So definitely in our board examination, in 12th board examination, you can expect one question under a 1 mark, or it can be under a 2 marks to come with integration by substitution. So let me give me another example. So the second problem, let me take. So another problem given is, we are supposed to find the integral of log x the whole squared by x dx. So now, seeing the integral, what can you infer? I cannot take x as t, because when I take x as t, dx will give me only dt. But here I have in the numerator log x. So what can be done is that you can take t as, so what can you take as t? Let t is equal to log x. So you can take t is equal to log x. So when I take t is equal to log x and try to differentiate, so I am differentiating. So when I differentiate this t, what I am going to get? So dt is 1 by x into dx. dt is nothing but what? 1 by x into dx as per the formula. So now you can see here in the problem, you have 1 by x, okay, 1 by x into dx, that is nothing but dt. So the given integral changes to, so this, let me take it as 1. So now 1 becomes integral, what is log x? This is nothing but t. T the whole square, and 1 by x dx is nothing but dt. So now you can see the formula, it has become very simple as integral t squared dt. So what is integral t squared in terms of dt? So we know a formula, integral x power n dx is nothing but x power n plus 1 by n plus 1 plus c. So using that formula here, this becomes t cube by 3 plus c. But you have to replace, okay, you have to replace this t finally. Don't forget to replace this t because the final answer will be only in terms of the given variable. So the answer becomes, what is t? We have assumed it as log x. So log x the whole cube by 3 plus c. So this is our answer. So this will be our given answer. Hope you understand. So seeing the problem, it seems to be a little difficult, but once you get practice with all these integral formulas and the methods which you are implying, by practice you will be able to understand what to take it as t and how to take it as the simplified form, and it becomes easier. So definitely you can expect one question from this integration by substitution method. Hope this is clear. So we'll take some other examples. So these two are the simple examples given for integration by substitution. It will becomes with a trigonometric, it becomes little more complicated. So we'll see such problems like that. Let me take another example. Integral x by e power x squared dx. Integral x by e power x squared dx. So now when you consider this formula, this integral, the thing is that the only thing which you can do is by substitution method. So when I take x as t, I'll be able to get dx is equal to dt and nothing can be done. So what I can do is that I can just take this term x squared term as t. So what I can do, I can take, let t is equal to x squared. So when I take t is equal to x squared, what I'm going to get when I differentiate? So when I'm going to differentiate, what I get, dt is equal to 2x into dx. 2x into dx. But what I have here, you have to see the problem also. What I have here, I have only x into dx. I have only, so x into dx. So what can be done? This becomes dt by 2. I can bring this 2 down so that x dx can be replaced by dt by 2. There's nothing wrong with bringing the terms down. It means the same because dt is equal to 2x dx and x dx also is nothing but dt by 2. So you can just easily infer x dx can be referred as dt by 2. So now in the substituting in the given problem, so this 1 becomes what? So x dx has become dt by 2, and what is there here? E power, and what is this x squared? Actually, I have taken it as t. So dt by 1 by 2 e power t, the constant can be brought out. So 1 by 2 is brought out, and this e power t can be written as e power minus t into dt. So e power t, when it comes up, it becomes e power minus t into dt, which is nothing but integral e power minus x is what? It is nothing but e power minus t into minus 1. So integral of e power x is e power x, and here you have minus t. So for that we are going to add 1 minus 1 and plus c. So what will be the final answer when you take? The answer will be, the final answer with this will be 1 by 2 e power, what is t? What is t we have taken? Nothing but e power minus x squared, and we have minus, so this minus will come here. So minus 1 by 2 e power minus x squared plus c. So this will be your final answer. This will be your final answer. So we can understand from what can you infer is that, so here you have one term with power, okay, and here also you have e raised to the sum of power. So wherever you have raised to the power of, okay, or something like that, with square root, something like that, we can just try to take those terms as t, so that the simplification becomes more easier, and you can just get out of the results. Okay, so this is another example. Next, we'll go with another example. Integral 1 by 1 plus cot x dx. So the given problem is like this. So how can I simplify this is that first I have to write this cos x. So 1 plus cos can be written as, cot can be written as cos x by sin x into dx. Now take LCM in the denominator. So this becomes 1 by sin x plus cos x by sin x into dx. So this becomes what? It comes to the numerator. So this becomes sin x dx by sin x plus cos x. Okay, so this becomes sin x dx by sin x plus cos x. So now what can be done is that directly I cannot use any substitution method, because there are two terms, and when I take either sin x as t or cos x plus t, then I'll be left out with some t plus something like that. It will not be easier for me to simplify. So what better I can do is that I can add and subtract this cos term, so that it will be easier for me to integrate. So when I'm going to add and subtract, so after this step, let me say that I'm going to add and subtract cos x term. So I'm going to add and subtract cos x. So when I'm going to add and subtract cos x in the numerator, where? In the numerator, for simplification. Okay. So when I'm going to add and subtract cos x in the numerator, this becomes sin x plus cos x minus cos x by sin x plus cos x into dx. And with this, when you split also, you will have other terms. So the possibility is that better I can make this as 1 by 2 into 2. In such a case, it will be simpler for me, because I'm multiplying and dividing with 2. The next step, it becomes the sin x can be written as sin x plus cos x minus cos x into dx by sin x plus cos x. Hope you understand. So to make the simplification easier, I have just added cos x. Okay, I've added and I've subtracted cos x, which makes no sense here. So because I've added and subtracted, it means the same. After doing this, I multiply and divide by 2, such that I'll be able to write 2 sin x as sin x plus sin x, which means the next step, I'll be able to take 1 sin x plus cos x term and it will get cancelled, and I'll be left out with 1 sin x minus cos x term, which means when I take one term as t, I'll be able to get the numerator. Okay, so with this, it will be easy for you to integrate. Okay, so let me proceed here after this. So after this, when I proceed, I'll be getting 1 by 2 is common, and integral, this can be written as sin x plus cos x, then once again with sin x minus cos x by sin x plus cos x into dx. So now I can write this as two different integrals as sin x plus cos x by sin x plus cos x into dx plus, once again, this can be written as sin x minus cos x the whole divided by sin x plus cos x into dx. So what will happen? This becomes 1. So 1 by 2 integral dx, and here when I take one term as t, I will be able to get the other term. Okay, but how this can be done is that, suppose if we had a minus sign here, so this minus sign is residual because when I take sign differentiation of sin x will give me only cos x, but here I have minus. Okay, so what can be done? You can take minus commonly out, and this can be written as cos x minus sin x by sin x plus cos x into dx. So now this becomes integral dx is nothing but what? X. So 1 by 2 x, because x power 0 means x power 1 by 1, so it is only x, and this becomes, so in this, the case of the second integral, what I can do is that, okay, so let me name this as the second part, and here I can use substitution. So when I'm going to use substitution for this part, I'll be taking, let sin x plus cos x is equal to t. So when I differentiate sin x, I'll be getting cos x, and when I differentiate this cos x, I'll be getting minus sin x. Okay, dx is equal to dt. Okay, so cos x minus sin x dx becomes dt now. So now substituting in the given integral, so when I substitute, this becomes what? This becomes dt, and sin x by t becomes t. So dt by t. So now this becomes 1 by 2 into x minus dt by t is nothing but what? Log t. Log t plus c. Okay, the constant is added overall, and the final answer would have been 1 by 2 x minus log of, what is t I have taken here? What is t I have taken? T is nothing but sin x plus cos x. So sin x plus cos x plus c. Okay, so this is what it can be done for the simple method. So this is your final answer. This is your final answer. So remember, the same problem can be asked with, instead of cot x, it can be asked with tan x. So in that case, you have to replace sin x by cos x, the same methodology. But when it comes with tan x, you are going to replace sin x by cos x. So the cos x will come to the numerator. And what you do is that you add and subtract sin x. You add and subtract sin x. So the problem means the same. Both are going to be the same. The only difference is that, so you can just remember, whenever it comes with 1 by 1 plus cot x, I'm going to write as cos x by sin x. What I can do is that I have to add and subtract to make the integration process simple. Otherwise, it becomes a little difficult for us to integrate because we do not have a direct formula with this fractional part, and we will not be able to solve it easily. Okay, so it's so simple once when you practice with all these concepts. So this is with a new method called as integration by substitution. So one thing which you have to remember is that integration by substitution, when you take, you focus on one term, you will be able to differentiate, you will be able to get the numerator term. And when you see the integral itself, you can just see that that comes with the power, as I said earlier, that comes with the raised to the power of, or that comes with square root. So such things, such terms can be considered as t, so that the entire method of integration using substitution becomes much simpler for us. And this is a very simple concept where we will be able to get it by practice. Now nothing big or nothing very difficult, you can say. It is so easy. Once you practice, you will be able to get with all these methods. Okay. Thank you. me do with another complicated problem. If the final problem with the fifth problem, let me consider. I'll do with another problem also. The final 5 problems we make it. Last problem which you consider. Fifth problem. It is given integral x cubed sine of tan inverse of x power 4 by 1 plus x power 8 into dx. So this is a given problem. So let us see what can be done so that you can make the integration process simpler. The only thing which you can do is that when it comes with the composite terms like x cubed, one algebraic, one trigonometric, and moreover it's a combination. The only thing which you can do is substitution method. And now when you decide that substitution method can be used, then you have to think what term to take it as t, so that it will be easier for us to make the other terms in the numerator. Okay, so the integration becomes simpler. So what I do is that what I suggest is that comes with an argument. Okay, that comes with an argument, because here there is no raised to the power of. If I take x cube, then nothing can be done. But here sine of one term is it. So this is called as argument. So better when you take this argument term as t, I'll be able to make the integration process simpler. So let me assume that I'll take t as tan inverse of x power 4. So when I take t as tan inverse of x power 4, so let me differentiate this. dt becomes, what is tan inverse of x? Tan inverse of x is nothing but 1 by 1 plus x squared. But here it is x power 4, the whole squared, which gives me 1 by 1 plus x power 8. Okay, so 1 by 1 plus x power 8. And what is this? If it was x means x squared, but here it is x power 4. So once again I am supposed to differentiate this x power 4. So it is 1 by 1 plus x power 8 into differentiation of x power 4 is nothing but what? 4x cubed. Differentiation of x power 4, x power n x power n minus 1. So 4x cubed. So this becomes, so dt has become 4x cubed by 1 plus x power 8 into dx. Okay, into 4x cubed into dx. So this has become. So let me see where I have any term like this as x cubed by 1 plus x. Yeah, here x cubed is there, by 1 plus x power 8 is there, and dx is there. So easily you can spot out. So only this 4 is extra. So when I try to bring this 4 down, I'll be getting the term there. So dt by 4 is nothing but x cubed by 1 plus 8 into dx. Now we can see that the entire term, that is with x cubed and 1 plus x cubed with this term and with dx, okay, I am going to get dt by 4. So now when I replace this, so the integral becomes dt by 4, okay, with the circle terms, this becomes dt by 4. And what is this? This is nothing but sine of, and what is this tan inverse of tan power 4? I have taken it as t, isn't it? So I have taken it as t. So sine t dt by 4. So what you can do, you can bring this 1 by 4 out, and this becomes sine t dt. So what is the integration of sine t? It's very simple. Yes, sine x is minus cos x. Sine x is minus cos x. So minus 1 by 4 cos t plus c. But I have to replace this cos t. So I'll be getting, so the final answer would have been, yes, minus 1 by 4 into cos of, what is this t which I have assumed? What is the t which I have assumed? It is nothing but cos of tan inverse of x power 4, okay, x power 4 plus c. So this would be my final answer. Okay, hope you understand. So when you see a complicated term, don't get confused. Immediately you see with an argument. Either it should be raised to the power of, or as I said earlier, that term which comes with square root, or that which comes with an argument. So these three terms, when you keep in your mind, you will be able to solve the substitution method easier. Okay, so this is the substitution method. So whenever a problem is given, first try with substitution method. If this substitution method is not working fine, we'll go with some other method. So the first thing which you have to see is that whether substitution will be possible. By seeing itself, you'll be able to identify, okay, whether substitution can be used or not. If so, you use substitution method. Otherwise, you can go with some other method further.